الرحيم waxaan noo socday chapterkii algebra qaybtiisa ugu dambeysay ayaan qaadanaynaa waa linear programming algebraic representation and manipulation chapter 7.6 that is linear programming. Learning outcomes. By the end of the lesson, learners should be able to represent linear inequalities graphically, use graphs of inequalities to solve simple linear programming word problems. Example number one. Given two constraints and one objective. The constraints are we have the constraint as x plus y less or equal to 20. We also have 3x plus 4y less or equal to 72. And then the objective is z is equal to 4x plus 5y. Always the objective, we have three unknowns. Now, linear programming, this one is normally used for optimizing, maximization, and minimization. This one is used for maximizing and minimizing, i.e. profits. Maximizing and minimizing, for example, profits. Now you're told graph the inequality below. So let's first of all graph this inequality that is above here. So what you do is, I'll start with the first one. Solution. X plus y, this will be equal to 20. So when x is 0, what is the value of y? When x is 0, y is 20. And when y is 0, x is 20. So that is the first one. The second one, x plus 3x plus 4y is equal to 72. And then you come up again with the table of values. So we have x and y. So when x is 0, 4y is equal to 72, meaning divide both sides by 4, you get 18. And when y is 0, that will be 3x is equal to 72, divide by 3, you get 24. Now the question above, you're told graph the inequality. We need to graph now this one. So we have these two. We have 0, 20. We have 0, 20, 20, 0. We also have 0, 18, and then 24, 0. So we need to graph these two. This is x and y. We always start with, when graphing, this is a solid line, this is also another solid line. So x will be greater or equal to 0, y will be also greater or equal to 0. So these two lines. So the first one we have 0, 20. Let's assume this is where 20 is. And then 20, 0, somewhere here. 20, 0. So this one, we have an equal sign, so meaning this line will be solid line. Solid line. 0, 18. 0, 18 is below 20. And then the next one is 24, 0. Assume this is where 24 is. Then again, solid line. So we will be shading the unwanted region. For example, this one, all the points below, they are all less or equal to the numbers above, they're all greater or equal to. You can prove by picking a number like 20, 20 is here. And then 20, for example, a number like 0, 0 is here. So you just pick two numbers, either one below and one above. We have proved before. So all these are below and all these are above. So I will be shading the unwanted regions. I will be shading the unwanted. We have wanted and unwanted regions. So this is my intersection point. So this is my region R. This is my region R. So this will be looking for this region. Now, question number 1 reads, identify the corner points. Identify the corner points. The corner points are 0, 0, 20, 0. We don't know this one is XY. And then we have another corner point, 0, 18. So let's first of all get this one. The intersection of the two lines, that is. The first one, we will use that using, we will be using elimination, and this is just a simultaneous equation. We have x plus y equal to 20, and then you have 3x plus 4y is equal to 72. Then just multiply this one by minus 3, and then this one by 1. You get minus 3x, and then minus y equal to minus 60. This one will be 3x plus 4y equal to 72. So this cancel. This is 3y. 3y will be equal to positive 12. So 3y will be equal to positive 12. 3y is equal to 12, meaning this one, you cancel this, you get, this is 3y is equal to, this one you get 12, and then you divide both sides by 3, you get 4. So x will be equal to 4. What is the value of y when x is 4? So you just put there, if this is 4, then you transfer this 4 to the right, and then you get 20. So 20 minus 4, you get 16. So the intersection point here, this will be equal to 4 and then 16. This is my intersection point. So meaning this is 4 and this is 16 and so on. Okay, question number C. Find the intercept. This is the intercept. Now determine the maximum profit. We said linear programming is used for maximizing and minimizing profits. So we are told to determine the maximum for z value. So therefore, to determine the z value, we'll be using the corner points. There you write x, and then y, and then the profit, which is z, you have 4x plus 5y. So the first one is 0, 0, x 0, this one will also be 0, because 4 times 0, 5 times 0, everything is 0. The next one, the corner point is 20, 0. So this will be, z will be equal to 20 times 4 is 80 plus 0 is 80. The next one is 4, 16. So 4 times 4, you get 16. 16 plus 16 times 5, you get 0 carry 3, 80. So 80 plus 16, you get 96. The last one, you get 0, 20. So multiply this one, you get 0. 0 plus 5 multiplied by this, you get 100. So you can see we have 100 here. 100. No, I'm sorry, this is supposed to be 18. 0, 18, I'm sorry. This is 0, 18. 18 multiplied by 5, you get 90. 18 multiplied by 5, you get 90. So the maximum is this one. This is the maximum. That is the maximum for question number 1. Question 2. Question number 2. Find the maximum and minimum values. Find the maximum and minimum values of 5x minus P profit 5x minus 3y give the visible region. So this one we are given. We just start with, there we have x and y. Then we have P, which is equal to, P is equal to 5x minus 3y. And then the visible regions are, start with 0, minus 2. Then the next one is 6, 2. Then the next one is 3, 4. The next one is 0, 2. And then you just substitute these numbers here. This is 0. You get 6. Minus minus is positive. You get 30. 30 minus 6, you get 24. This one is 15. And this is 12. 15 minus 12, you get 3. This is 0. And this is minus 6. Then the question is, find the maximum and minimum values of the function P, that is the profit P. So the maximum is this one. This is maximum. And this is now the minimum. Normally, linear programming is used for maximizing and minimizing profits. Example number 3. Example number 3. A farmer has 240 acres to plant. The total is 240 acres. He needs to decide how many acres of corn to plant and how many oats to plant. So he decides how many acres of corn and how many acres of oats. He can make 40 per acre profit of corn. The corn he makes 40 profit per acre and then 30 for the oats. However, the corn takes 2 hours of labor per acre to harvest, and the oats only takes 1 hour per acre to harvest. Now he only has 320 hours. The total number of hours is 320 of labor he can invest. To maximize his profit, how many acres of each should he plant? Now step number 1, we don't know the number of acres for the corn, so you just write X. This one equals to number of corns. That is number of corns per acre, and then Y for again number of oats, corn or galleyda, and then oats na waxa loo yaqaana miraha. Okay. Now x plus y is less or equal to 240. This is the corn and this is the, what do you call, oats. They add up to or less or equal to 240. The next one is the number of hours. This one takes 2 hours to harvest. This one takes only 1 hour to harvest. So this is less or equal to 320. The profit per acre for the corn is 40x, and then the profit per acre for the oats is 30. So this is 30y. That is, y is the number of acres. So we need to first of all draw these ones. I'll start with the first one. X plus y is equal to 240. So just come up with table of values. When x is 0, when x is 0, y is 240. And when y is 0, x is 240. The next one is 2x plus y is equal to 320. 320. So when x is 0, what is the value of y? When x is 0, y is 320. And when y is 0, x is 160. Because 2x is equal to 320, divide both sides by 2, and then you get that. So I'll try to now plot. I'll plot these ones. I'll plot this one. 0, 240. Assume this is 240. 0, 240 is there. And then 240, 0, somewhere here. Then the next one is 0, 320. 320 is above 240. And then this one is also 160. 160 is below here, below the 240. So we have, these are solid lines, so you join the points using a solid line. And this one you also join. Still, this is less or equal to, and this side is greater or equal to. So we shade the, let's shade the unwanted region always, so that we can come up with region R here. So this is my region R. These are my corner points. These are my corner points. So my corner points, I don't know this one. I will be finding the corner points for that. And I'll be finding the corner points. The corner point is x plus y equal to 240. And then 2x plus y equal to 320. So multiply this one by -1 and then +1. You get minus x minus y equal to 240. This one is 2x plus y is equal to 320. Therefore, you cancel these two, you get only x, and then you get 120. 120 or what? This is 80, I'm sorry, this is 80. So when x is 0, what is the value of, when x is 80, I mean, what is the value of y? Just put 80 here and then you transfer. You get 240 minus 80, you get 160. So my corner points, this is x, which is 80, and then the next one is 160. So this one is 80 here, meaning, and this one is 160. Now the question is, you're told to calculate the profit. Calculate the profit. Calculate the profit. For you to calculate the profit, this is how to do it now. Just write x here, and then y, then the profit, 40 per acre for the corns, and then 30 per acre for the oats. So start with the corner point. You first of all list the corner points. You have 0, 0, and then 160, 0, 240, 0, 80, 160, and then finally 0, 240. So these are the corner points. 0, 0, 160, 0, 240, 0, and then 80, 160. What else? 80, 160, 0, 240. So 0, 0, everything 0 here. You get 0. Put 16 times 4 is 64. 6400. This is 6400. Because this one is 0. Because if you multiply 30 by 0, you get 0. So 24 times 4 is 96. You add 2 zeros. 96 double zeros. This one is 0. 80 times this one, you get 3,200. And then you add 30 multiplied by, I was multiplying by 60. 60 multiplied by this one, you get 4,800. So once you add these two together, 80 times 40 is 32. And then 16 times 3 is 48. 48 and then 2 zeros. Add these two together, you get 80. You get 80, yes. You get 80. Then 240, this is 0 times 240, there you get 7,200. So the maximum profit, this is now the maximum profit. That is the maximum profit. Marka ashirka intaas ku dhan yahay maanta.